Lesson 13, Part 5. Today we are going to be working on comparing and ordering numbers in scientific notation. So it's easier to compare numbers when they're all written in the same form. So the good news is you can choose which form to use, either standard form or scientific notation. Standard form, let's take a look at this. We're looking at place value chart. So if we find our decimal, if we're going to get our number bigger, we're going to go at ones, tens, hundreds, thousands, 10,000, 100,000, millions, and it keeps going. If we're going the other direction, to the right side of our decimal, it goes tenths, hundredths, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, and so on. So what we're going to ask you to do is arrange in order from least to greatest. And we want you to use this place value chart where appropriate. So in one of the problems, this one, we have to put these four numbers in order from least to greatest, or smallest to biggest. So the very first thing that you should do, it should help to have them lined up using the decimal point. So take each one of these numbers, 0.042, 0.043413, and you're going to take each four of the four and just line up your decimals. Nice and easy. Then, from there, you're able to determine which one is smallest, which one's biggest. So what's starting with our place values. So let's look for obvious things. So I'm going to start in the ones place. 4 is clearly the biggest, as the others have zeros in the one place. So we know that one's going to be our 4. Our answer will be 4 over here. This is our fourth number because we're going from least is 1, greatest is 4. Then let's go to the next place value. We're just going to work to the right, which is our tenths place. Remember our place value chart. 0, 0, 0. Oh, they're all the same, so we can't use tenths. So let's go to the hundredths. 4, 4, 0. So 0, this one has to be the smallest, as the other two have 4 in the hundreds place, and this one has a 0. So this 0 is smaller than the rest. So this one's going to be our smallest. So this is 0.0048 will be our smallest number. So this will be a number 1, this will be a number 4, and then we got to determine the remainder. So now we're moving. So we have tenths, hundredths, thousands place. 2 and then 1. This one's bigger than the other number, as it has 1 in the thousands position, and this one has a 2. And so what we said, 0.0048 is our smallest. Our next smallest is 0.0413. Our next smallest is 0.042. And our biggest is 4.2. So it's going to be in that order. Next, we need to arrange in order from least to greatest. This time, you notice we're going to have a mix of numbers. We have some that are in scientific notation, some are in standard form. So what we need to do is convert them all to be the same. So let's rewrite them so they're all in the standard form. So if we had 8.2 times 10 to the second, that means we're going to move our decimal 2 places to the right. So 1, 2. So it should be 820. Then 82,000, 8,020,000, and 8.02 times 10 to the 4th. So moving our decimal 4 places to the right. 1, 2, and then add 2 more zeros. So that'd be 80,000. 80,200. So then we have to line up our decimals. This one's definitely the smallest. Then we could say this one's going to be our biggest. And we have to compare the 82,000 with the 80,000. This one is smaller than the one remaining. So our answers go from our smallest, 8.2 times 10 to the second, 8.02 times 10 to the 4th is our second biggest. Our third biggest is 82,000, and last, our biggest is 8,020,000. So the big key here, when you have a mix of scientific notation and standard form, make sure you put them all in standard form. Line up your decimals. Our decimals would be all at the very end. When you don't see a decimal in a number, it's always at the end. Let's do the same thing. This time these are all in scientific notation. So let's take a look. If we notice that how they all have the same exponent, we have 3.6 times 10 to the 8th, 4.75 times 10 to the 8th, 2.07 times 10 to the 8th, and 3.12 times 10 to the 8th. So they all have an exponent of an 8. So all we need to do is rank the numbers in front. So if we just put our numbers straight out, 3.6, 4.75, 2.07, and 3.12. Being that they all have the same exponent and they're in the correct form of scientific notation, means that there's only the number in front is between 1, it could be 1 or less than 10. So these are all, so it's only one digit in front. And they all do. We line up our decimals and we can just put them in order. Our smallest, well, 4.75 is our biggest. Our smallest is 2.07. And then we have to compare. We have 3 and 3. We go to our tens place, 6 and 1. So 1 is smaller. This one's smaller than the other one because it has a 1 in the tens place versus the 6. So it goes in this order. 2.07 times 10 to the 8th. 3.12 times 10 to the 8th. 3.6 times 10 to the 8th, and then lastly our biggest number is 4.75 times 10 to the 8th. Real easy to do when you have the same exact exponent. All right, how about if we have scientific notation again, but this time we have 2 times 10 to the 5th, 3.25 times 10 to the 2nd, 2.7 times 10 to the 6th, and 3.2 times 10 to the 8th. We notice they're all in correct form. Our exponents are different this time. So what should that notice? That means that all you need to do is rank based on the size of the exponent. So all we're doing is looking at the exponents, but they're all different. So we have 10 to the 5th, 10 to the 2nd, 10 to the 6th, and 10 to the 8th. So we just put them in order. Our smallest would be 10 to the 2nd, our largest is 10 to the 8th. Then we look at our next, 10 to the 5th would be the next smallest, and 10 to the 6th would be our next biggest. So it's going to go in this order. 3.25 times 10 to the 2nd is our smallest. Then it's 2 times 10 to the 5th. 2.7 times 10 to the 6th. And lastly, our largest is 3.2 times 10 to the 8th. So just a recap on this one. When everything's in proper form, scientific notation, we look at, and they have different exponents for each one, we just look at the exponents. Our largest exponent, in this case is 10 to the 8th, is going to be our biggest number. Our smallest exponent, 10 to the 2nd, is going to be our smallest. Okay, so this one we're using, it's in scientific notation, and you notice they should be they're all in the correct form. This time we're having negative exponents. That's okay. So once again, we're going to put and they all have different exponents. So that means all we need to do is rank based on the size of the exponent. But be careful when comparing negative numbers. You got to think of which one is the smallest and biggest. So when we're talking about negatives, our smallest number is going to be our biggest negative. So 10 to the 9th will be our smallest. Our number closest to 0 is going to be our biggest. So 10 to the negative 2nd is closest to 0. And then this one, 10 to the negative 7th, is the next smallest because negative 7 is smaller than 1. And 10 to the negative 4th would be our third. So our smallest is 2.7 times 10 to the 9th. Our next biggest, we're looking at negative 7, so 3.25 times 10 to the negative 7th. Third, 2 times 10 to the negative 4th. And lastly, our biggest number is 4.2 times 10 to the negative 2nd. Really be careful on the negatives. Remember, our biggest number is going to be the number, our negative that's closest to 0. Our smallest number is going to be furthest away from 0. So our bigger negative. in this case, -9 is bigger than -4, -7, and -2. All right, let's try this one. So if we notice this one, we have a mix of scientific notation and standard notation. So this time they aren't already in the same form. So let's change them all to scientific notation. So our first one's done for us, 3.75 times 10 to the negative second. This one we need to convert into scientific notation. So I'm going to move my decimal, 1, 2, 3. So our decimal is going to be between 3.5. So 3.5, that's going to be in front, times 10. And since we moved it, 1, 2, 3 place values, our number is small, so it's going to be a -3 for our exponent. 3.5 times 10 to the -4 is already in scientific notation. And our last one, we need to convert to scientific notation. Our decimal is going to fall between the 3 and 7. So we're moving it 1, 2, 3. So it's going to be 3.7 times 10 to the -3rd. Okay, so we all have them in scientific notation. Let's take a look at our exponents now. -2, -3, -4, -3. So we should be able to work with these a little bit. So when we're looking at our exponents, which ones are biggest, we can just look at our exponents and determine which one's biggest. So our exponent -2 is closest to 0. So that one's going to be our biggest. Our smallest is going to be the one that's furthest away from 0, which is -4. Now, the little hang up we have to be careful with, we have 2 left that have the same exact exponent. So now we have to look at our number in front. So 3.5 and 3.7. And 3.7, the last 2 have the same exponent, so you have to compare the numbers. So 3.7 is bigger than 3.5. So 3.7 times 10 to the -3rd is bigger than 3.5 times 10 to the -3rd. So if we put these in order from smallest to biggest, 3.5 times 10 to the -4th is the -4th exponent is furthest away from 0, so that makes it smallest. Our next is, we converted this, our second one, to 3.5 to the -3rd. So that's 0.0035. Our next is 0.0037. And our biggest number is 3.75 times 10 to the -2nd. All right, so be careful with these, but the big thing that we want you to come across today and learn is you have to have the same, if either they're all going to be scientific notation or all standard form. So you're able to tell which one is smallest to biggest. All right, so let's use greater than, less than, or equal signs. Again, it's easier to compare when it's in the same form, and is your choice of what form you like to use. So we have 8.7 times 10 to the -2nd, and then we have the standard form of 0.0875. So I'm going to convert our scientific notation into standard notation. So what's this telling me? We have to make our number smaller, so I have to move my decimal 2 places to the left. 1, 2, so I'm going to add a 0 in front. And that's with this number. Now we're going to compare these two. They're both in standard form. So zeros are the same in the ones place, zeros are the same in the tenths place, eights are the same in the hundreds place, 7 is the same in the thousands place. But then we have one more decimal in this one. It's 5. Well, when we don't have a number showing, it's assuming there's a 0 at the end. So if we line these up, we can clearly see, so it's the same, same, same. This one would be bigger because of the 5. So because we can add that 0. So a smaller number in the thousands place, 0. So we'd say that 8.7 times 10 to the -2nd is less than 0.0875. Let's take a look at this one. 2.03 times 10 to the 8th, comparing it with 2,030,000. This time, let's convert it to scientific notation, this one. If we did that, our decimal's at the end. I want our decimal to fall right here between this 2 and a 0. So I want to move it 6 places. Our number's big, so it's going to be a positive exponent. So our answer is going to be 2.03. I want to drop off our zeros. And since I moved it 6 places, it's going to be 10 to the 6th. Now if we look at this, being that we have different exponents, we can just see which one is bigger. 8 is bigger than 6. Smaller exponent, so smaller number. So our answer is 2.03 times 10 to the 8th is greater than 2,030,000. All right, let's continue on. Try these on your own. Why don't you pause the video? All right, let's take a look. Both of these are in scientific notation. They're in correct form. So all we need to do is look at our exponents. We have a 5 and a 3. They're different. So then we look at which one's bigger. And let's get these. So this 3 is smaller than the 5. So that's going to show us that 2.35 times 10 to the 5th is bigger. So that's going to be greater than 4.8 times 10 to the 3rd. Let's look at 4. 9.1 times 10 to the negative 5th. And we're comparing it to 0.000091. So we need to convert one of these to either scientific notation or standard form. I'm going to convert it to scientific notation. So we want our decimal to fall between the 9 and the 1. So we're moving it 1, 2, 3, 4, 5 places. So that's going to tell us that's our exponent. And being that our number is small, we say it's small when our ones place is a 0. So it's going to be negative 5 since I moved it 5 places. So our answer is going to be 9.1 times 10 to the negative 5th. Now let's take a look at our exponents first. We have 10 to the negative 5th, 10 to the negative 5th. They're the same, so we have to look at the number in front. 9.1, 9.1. They're the same. They're equal. So we just put an equal sign. In our last example, 4.8 times 10 to the negative 9th, and we have to compare it with 0.00000048. So let's convert this number into scientific notation. When we do that, we want our decimal to fall between the 4 and the 8, and we're going to count it 1, 2, 3, 4, 5, 6, 7, 8 places. So a scientific notation would be 4.8 times 10 to the negative 8th. The reason why it's negative 8 is because it's a small number. The ones place is a 0. All right, so now what we're doing is we're going to compare our exponents. This negative 8 and negative 9. Which one is smaller? The negative 9 is further. It's a bigger negative. It's further away to 0 compared to the negative 8. So this negative 8 is larger than comparing it to negative 9. So 4.8 times 10 to the negative 9th is less than 4.8 times 10 to the negative 8th. All right, that's it for today. If you are having any questions or you're hung up on any of this, please ask your teacher. Have a great day.